Right, we're at the last set of questions now. Hooray! So we're going to look at question 19. And it says here the volume of S is this, so 576 pi centimeters cubed. And helpfully they tell us, we know that this is a quarter of a sphere, and they tell us the volume of a full sphere, can't even say it, tired now, is this. And the surface area is 4 pi r squared. Now this is for a full one, remember? What they want is the surface area of this shape here. So that's quite a tricky question, to be honest with you. It's got 5 marks because there's a lot going on here. So I want to go from the volume to the surface area. So first of all, I know the volume here, that's of a sphere. So various things I can do here is I'm going to times that by 4, because that gives me the total volume of a sphere. So 576 times 4. Don't worry about the pi. So that means it's 2304 pi. You don't have to, that's already times, because just 4 times it, you times that together and the pi stays there. Now we know that that volume is equal to 4 over 3 pi r cubed. So now I can cancel out the pi's. And then what I'm going to do is times that by 3 and then divide it by 4 to get me what r cubed is. I'll say that again. I'm going to times that by 3 and then divide it by 4. And that gives me what r cubed is. And then I'm going to do the cube root of r. Oops, a daisy, not that one. Cube root of r, shift pi. It's 12. Oh, that's nice. That feels good. So I know the radius is 12. Now I need the surface area. Now forget not that there are 3 areas here. You've got the quarter of the ball, which is effectively that. So if you look at this sort of surface area, the curved surface area, that's a quarter of what they want here. So that's 4 pi r squared. That's convenient because that cancels out. So it's literally going to be pi times 12 squared, which is 144 pi. So that's 144 pi. And now I've got to work out the area of the 2 smaller bits. So how do we do that? Okay. Well, we know that this here, that is the radius of 12, and this is half a circle. So half a circle. So it's effectively a whole circle, isn't it? So both halves make a whole. So the area of a circle here, where the radius is 12, is pi r squared, if you remember. So again, that's 144 pi. Now that's really quite something, isn't it? So effectively, if I do 144 pi plus 144 pi, I should get to what they want us to get to. So 144 shift pi equals, oops, do it properly. So 144 times shift pi equals that, and then times that by 2 equals 905. There you go. Kind of neat. And they want it to 3 sig fig. So there you go. It's quite a tough question, but done. Right, this next one is only worth 2 marks. This it's a strange one. Rationalizing the denominator. To rationalize the bottom number, we must times it by 2 minus root 3. So he's done correct there. But whatever you do to bottom, you do to the top. Now let's just have to go through all these calculations. Let's look at the top. 14 times 2 is 28. 14 times root 3 is that. Brilliant, good. Now let's just look here then. 2 times 2 is 4. Plus root 3 times minus root 3 is minus, there you go. So it should have been a minus there. So what he's done is plus root 3 times minus root 3 should equal minus 3. And that's what you'd write. It should be minus 3. This one here, rationalize the bottom denominator. Well, you're going to simply times top and bottom by root 12. Done that correctly. Oh, look, here we go. If you do root 12, that is the same as root 4 times 3, which is root 4 root 3, which is 2 root 3. And they've got 3 root 2. So it should be 2 root 3 instead. Right, the last question, question 21, is quite complicated. So what I've done actually is I've actually answered it already, and I'm just going to walk you through all of this. It's quite a tough question. Jackson's trying to find a density, and he's measured it, but to certain degrees of accuracy. He hasn't got it exact, because how can you? So he knows that these dimensions are measured to the nearest millimeter, and the weight to the nearest 5 grams. So if we want to know what the, it says by considering bounds, work out the density of the word to a certain degree of accuracy. So density, as they gave, is grams over volume. Maximum density would be this triangle here, wouldn't it? So it would be maximum mass over minimum volume. And the other way, minimum would be minimum mass over maximum volume. So to work out the minimum volume here, I take the lower bounds here. 13.15, so it's to 1 millimeter, so it's actually half a millimeter below in these here. Multiply them all together, and that's my volume. But of course, my mass is going to be the maximum one, and if it's to the nearest 5 mil, then it goes up and down by 2.5 each time. Sorry, 5 grams. It goes up and down by 2.5 grams on either side of the limit. So it's plus or minus 2.5. So I'm going to get the maximum here of 1972.5, and as I say, I do mass over volume, so that over that gives me this value here. Now I do the same for the minimum, but this time I'm going to use the maximum volume. So in this say, instead of going 0.15, it's now 0.25. Do all of that and you get this maximum volume they could possibly be. Divide, and then we've got the minimum mass. Again, remember it's plus or minus 2.5 because they say the bounds is every 5 grams. So it's plus or minus 2.5. So that's minimum mass. Minimum mass divided by maximum volume is that density. Now they want to know, calculate what the density of the wood is to the nearest degree of accuracy. Now if I round this to 2 decimal places and round that to 2 decimal places, they both come out at 0.43. If I did that to 3 decimal places, it will be different. Okay, I could do it to 1, but I want to have the most suitable degree of accuracy, and it's the best one here is 0.43. So that is your answer. Quite complex really. That's the end. Hope you did well.